Hi everyone, thank you so much for joining us today. We have with us Dr. Oana Ignat for a guest speaker session. Dr. Oana is a postdoctoral researcher at University of Michigan and incoming assistant professor at Santa Clara University. Her research interests are at the intersection of language and vision, where she aims to develop equitable models that would work equally well across demographics such as income, race, gender, language, and culture. She is passionate about research applications for social good impact and use of AI to attract and retain minorities in computer science. Her work resulted in several publications in top conferences such as ACL and EMNLP, and she is also a co-organizer of the NLP for Positive Impact workshop at EMNLP 2024. Dr. Oana is also involved in several outreach programs, including co-organizing ACL Mentorship Global Panel Sessions and many other events and workshops centered on improving diversity in computer science. Thank you so much for your time, and I'll pass it over to you.
Thank you, Ahmad, for great introduction and for making this event possible. So I'm really excited to be here and present our paper. It's called Has It All Been Solved? Open NLP Research Questions Not Solved by Large Language Models. So I will start with a little story. It was 2018, and I was at Calling in a conference in Santa Fe, New Mexico. It was my first PhD conference. I just came from Romania, and I was fairly new to everything, but I remember Professor Zmienian Khan keynote presentation about research fast and slow, but I didn't really quite understand it at that time. I was thinking how my research is going slow, of course, so I might not be affected by this phenomenon. And he presented a great analogy with how our brain works, always switching between system 1 and system 2, where system 1 is responsible for the fast, automatic thinking, and system 2 is more slow and controlled, responsible for the analytical thinking. And I'm curious if you can guess what system AI models are. So in this context, looking at the NLP literature publishing trends over the years, I realized that Professor Khan was already predicting how our field is moving towards fast or maybe too fast thinking. And also that we should not forget about slow research, because slow research is often more impactful, especially on the long term. This fast-moving field also led to a higher barrier of entry for beginners, and especially for underrepresented students in computer science. And together with Zijing and other amazing co-organizers, we decided to create a global mentorship program called ACL Mentorship, where everyone can ask questions live to experts in the field, in NLP especially, from academia or industry. And by far the most popular questions we received were these ones: what should I work on? How to choose a research topic? How to start with research? How to find a mentor, internship, PhD advisor, and so on. And maybe the first question we should ask is why a PhD, or why do research? And I'll let you think about this for yourself, your own question, your own answer for a few seconds before I share mine. So for me, I wanted to have my own ideas and propose them to others, and also have the knowledge and confidence to do this. And I can tell you it's worth it. It's really great to have all this and finish the PhD. So back to the most popular question we receive in the mentorship sessions: what should I work on? Well, if you don't have an idea prepared. Many times it's up to your advisor. And this is okay, but if you want to feel more empowered, it's good to think about this question for yourself. What are you curious about? What you want to learn more about during the PhD or during your research project? Well, now it seems that LLMs are guiding the answer to this question because their impressive performance led many researchers, especially at the beginning of their careers, worry about what NLP area to focus on. And we also received many questions along these lines. Has it all been solved, or what remaining questions can we work on regardless of LLMs? On top of that, the compute required to use LLMs poses another barrier of entry. We need to find solutions with reasonable computational costs, achievable with setups more available in academia labs. And building systems that cannot function without a paid API is also not well aligned with academic core research goals. So in this paper, we identified 14 different research areas that encompass 44 research directions that require new research and are not directly solvable by LLMs and are also rich for exploration, so one could do their PhD thesis on. They also do not depend on a paid API, and they can be achieved with reasonable computational costs. And this is an overview of the unsolved research areas that we present. And this, of course, these 14 research areas are just a few. They're not exhaustive, and many others exist. And we also welcome suggestions and feedback in our paper. We split these areas into three main categories: applied NLP, responsible NLP, and fundamental NLP. And I will enumerate the 14 research areas. They're the main challenges that LLMs face in these research areas and alternative solutions to explore. And I will start with the ones under the fundamental NLP category. So under fundamental NLP, the first research area rich for exploration beyond LLMs is multilinguality. Because current NLP solutions majorly focus on a few high-resource languages, although there are more than 3 billion low-resource language speakers, mostly in Asia and Africa, as you can see in the figure. And LLMs cannot solve these research directions, particularly due to the lack of training data. And because the current NLP solutions work mostly for English and several high-resource European languages, but there are much more speakers of low-resource languages in the world, about 3 billion, who don't have access to this technology. So there's plenty of work to do in this direction. Another problem is code switching between languages or between dialects. This is very common for us to do in everyday conversations, but currently is not supported well by NLP models. LLMs do not excel at reasoning either. Their objective, the next word prediction objective, can easily encourage the LLM to assign a high likelihood to invalid reasoning. And there are alternative solutions to explore, such as incorporating symbolic AI or adding external tools like calculators or search engines. And we also need to consider the data. It's important to have data from different social contexts and cultural backgrounds. And most importantly, we also need to reach a consensus on what reasoning is. to formally define reasoning and also design an evaluation framework. Very similar to evaluating multi-step reasoning. And we presented more details in the paper. Another direction rich for exploration is knowledge bases. This is one of my favorites. Data sets and annotations are very important for the AI community, and at the same time, they are very expensive and time-consuming to construct, to create well. And it would be great to find better ways to construct them. And no, I'm not saying we should construct them using LLMs. This is not a solution, especially if you also use the LLM to evaluate the annotations created with LLMs. I've seen this a lot, and I don't think it's correct. Real life data about people is much more complex, and you can take, for example, the cultural specific data. Currently, we are mainly focusing on surface culture, for example, food or music, clothes, language, but there is so much more to study, such as deep culture, for example, people's assumptions or concepts of fairness, notions of self, and so on. So if we leave this to LLMs, there is a great risk of oversimplification, stereotyping, and cultural homogeneity that future models and data sets are going to capture. Language grounding is another favorite research direction of mine. Different modalities like language and vision, they often complement each other and thus can potentially reduce the need for billions of data points. However, in some cases, these modalities end up competing with each other. So how to best fuse them is still an open problem. And at the same time, in real-life complex applications like measuring driver alertness or depression detection, it is very useful to use less studied modalities, for example, physiological or sensorial, behavioral data. Collecting this kind of data is difficult as it requires complex hardware, sensors that LLMs currently don't have access to. And speaking of complex hardware, child language acquisition is also a valuable source of inspiration for the sample-efficient language learning. So by mimicking the learning strategies of children, models can achieve better generalization with limited training data. LLMs currently require far more data than children need to acquire language, and LLMs can be improved in sample efficiency by learning how children acquire language. However, there are currently only very few language acquisition benchmarks, so NLP and multimodal systems could bring opportunities to scale up to ease construction of such language acquisition benchmarks. Well, how many of you have pets? I'm really curious. You can post in the chat or raise your hand. Okay. Around 6, 7. Okay. Let's say around 10 people. 9. Oh, wait. It counts the raise hands for you. Great. Then, yeah. 10 out of 50 or even more. Okay. A lot of pet lovers here. Nice. Thank you. So, yeah. How many of you want to understand them? Okay, everyone. Everyone who has pets. So yeah, this might be possible in the nearby future. You can check out Project SETI or Bark GPT, if you have dogs. So this is another area where LLMs are slowed down by the lack of training data, and because it is really difficult to acquire this data. If you don't believe me, just try recording your dog for a day and see what kind of data you get. And yeah, at the same time, we also have, when we have conversations, we use a mix of verbal and non-verbal signals, such as gestures, facial expressions, and how to use this data is currently rarely studied. Well, next I want to continue with the responsible NLP category, but I wanted to pause for a bit if you have any questions from the previous category or any questions until now. Okay, then if not, we can also take questions at the end. So moving to the responsible NLP category, it is important to know that many NLP applications that have a positive impact can also be used in harmful ways. So to think of the dual use of AI systems. So the research community should foster interdisciplinary collaborations to fight against these malicious applications of NLP technologies, such as deceptive text generation or misinformation campaigns. Generative models also have been found to show harmful stereotypes in downstream tasks. For example, in reference letter writing. And most existing work focuses on the unlimited aspects of data, such as gender, and fewer works focus on other aspects, such as the income or race or the intersectionality of all these different aspects. And finally, we need to work together with policymakers to establish standard approaches for attribution of the machine-generated data. For example, defining copyright and plagiarism in this context, especially for domains like programming or creative writing, where LLM-generated content is on the rise. One promising research direction is to investigate the internal representations of NLP models, including LLMs, by designing probing tasks that reveal the word knowledge captured by these models. So while probing considers the features learned by the model, another area called mechanistic interpretability aims to uncover the algorithms that contribute to the decision-making process. And these models aim to extract computational graphs from the neural networks and also reverse engineer the entire deep neural network. And this can really help us understand the reasoning capabilities of models and also identify potential biases. Incorporating human in the loop or human feedback to enhance the model interpretability can also improve model transparency and facilitate better decision making, and also foster the trust between AI model and users. In this area, there's also multiple promising directions like active learning or interactive explanation generation. And finally, as model-generated text is prone to hallucinations, a promising way to improve its reliability is to explain the conclusion step by step and also supply references or sources to back up the claims. Such examples are chain of thought prompting or retrieval augmented generation models. I also want to ask you if you know the answer to this question. So given if one passenger New York, San Francisco flight has 0.99 CO2 tons, how many tons of CO2 requires training GPT-3? Any guesses or any numbers come to mind? You can also post them in the chat or say out loud. Really curious what you think. 20 tons, 1.7. Other numbers? Around 100, 100. Okay, let's see. 12. A lot of variety here. Well, actually, if you look at this graph, based on Dr. Sasha Lucioni's work published in the 2023 AI Index report, we can see it's 502 tons. It's much higher than any number. I think 100 was the biggest number you said. Yeah, you can compare it, to put things in perspective, you can compare it with the CO2 released by other activities like, as I said, air travel or human life average. So yeah, we can see it's a clear need for more efficient models. And this current trend is also not feasible in the long run. So we need to find strategies to optimize data usage. For example, we can look into active learning and also look on how to efficiently adapt the models to downstream tasks. For example, we could update only a small subset of the parameters. Also, with the rising capability of text generation and also the strong commercial and political interests, it is inevitable to not see an increase in online misinformation. And there is a large need for fact-checking technology across different languages and different modalities. Because LLMs are prone to hallucinations and factual inconsistencies, they are also not sufficient to combat misinformation. So another direction is to ensure content diversity. With the prevalence of LLMs or LLM-generated content, the majority's voice is going to be amplified on the web. And similarly, content moderation techniques might also overlook the nuances of expression in underrepresented groups. So it's really important to trace what topics and opinions are filtered or demoted on the internet and why. And finally, after discussing research in fundamental NLP and responsible NLP, I also want to show some areas in applied NLP in various domains. But again, I'll stop if you have any questions until now. You can also ask in the chat. Okay, someone asked, what's your view on the human psychological principles in LLMs? I'm not sure, I don't know what you mean, the human psychological principles. Maybe give some examples. Otherwise, I can also, I'll leave you time to think, to give some examples, and I can come back at the end of the presentation. Okay, so backtracking hallucinations based on how we human actually make errors. That's interesting. Yeah, I don't know about that, backtracking hallucinations. Well, LLMs do have hallucinations, but it would be interesting, yeah, to compare how humans make errors versus LLMs make errors. I think that that's also related to the child learning and getting inspiration from that field. Also, will we be seeing more collaboration between neurobiology and NLP for developing reasoning? I think that's a good, so I always encourage interdisciplinary collaborations to learn from each other. A lot of times AI or computer scientists don't know everything, right? Like, we're trying to tackle these huge problems, but we don't have all the knowledge required. So it's great to collaborate and, yeah, try to form these relations with other disciplines and learn from each other. Also, is LLM explainability close to LLM interpretability? Well, there's explainability and interpretability are closely related, and there's a lot of diagrams on the internet and articles that explain this much better than I do. So yeah, there's a difference. One is using looks at the output, tries to explain based on the output what the model is doing. And in the other, you try to understand the model itself. So yeah, they're closely related, but they have a bit different differences. Okay, also I feel more of the problems like factual inconsistencies or even hallucination has been viewed as prompt engineering problems. Are there any other heuristic approaches that makes it more optimized? I see. Yeah, prompt engineering has been very popular, I agree, and seems to be very interesting to continue exploration. I think also other approaches are always welcome, right? Like, it's good to think out of the box and try other heuristics. Let me see, I'm not sure if I can think of others right now. Do you see research heading more towards abstracting human biology to ML, trying to replicate more closely the human mechanisms, the modeling synapses, axons, areas of the brain? And that's also very interesting. So this is also related to interdisciplinary collaborations. And that's another area of research, looking more closely to the brain, human brain, and how it's constructed. Like, the neural networks try to imitate that in a way, but much more simplified. So there is a lot of literature in this field. So I recommend looking through that. Also, are there any outlines we may have on what entails good research, referring to your initial point on slow research and exploration on these topics? I see, good research. Well, I don't know if to come to such a what is good research, what is bad research. When I said research right now is going very fast, and maybe we don't have time to think deeply about the problems we solve. So that's why I said slow research is also very welcomed, and unfortunately it's very rare nowadays because of this constant need to publish. So I think good research is any research that it requires thinking deeply about the problem you're trying to solve, to be an important problem for you. Also, something that you think will contribute to the society or the field. And I know this is very subjective or a very big statement, right? Like, and this contribution can be in various levels, doesn't have to change the field completely. Very few research papers do that. Most of them just push a bit more the boundary of knowledge, and that's completely fine, right? Because we can build on top of them, and then together we change the field. And regarding this question, also, I thought about this myself, and I think it also depends. Well, I'm gonna reiterate what I said in the beginning, how to find your research topic. I'll get back to that. But it's also very personal, right? Like you should find something that you're interested in, you are curious about, so you have this drive to work in the subject even when things are not working. Okay, great. Thank you so much for your questions. I'll get back to the presentation. Let's see. So yeah, I reached the applied NLP direction, and healthcare is a domain that also suffers from data scarcity. And this is usually due to the data unavailability or inaccessibility in this field due to privacy or ethics concerns. But even so, NLP has shown great potential in enhancing the communication in healthcare between patients and doctors, for example, by simplifying the medical jargons for patients or developing educational tools for healthcare professionals. However, LLMs may only be useful in limited settings because trust in LLMs also has been shown to depend on the complexity of the answer or complexity of the questions. And regarding drug discovery, this is another research area where the hypothesis space for drug design is exponential. So NLP methods can assist clinicians to extract and analyze large amounts of information, for example, patents or literature, patient data, and they have great potential, but also the use of LLMs is limited because of their lack of transparency, and also we don't know exactly how they make model decisions. So especially in fields like healthcare, we really have to be careful how we apply them. Also, the rising capabilities of NLP systems have given rise to intelligent tutoring systems. This can generate target practice questions and also explain students' mistakes in a wide range of subjects like math or computer science, history, literature, and so on. But these systems also require human-in-the-loop checks also because the NLP models are still lacking when it comes to more challenging reasoning. And other challenges also include the lack of diverse data in the domain and also the user, and also privacy concerns. And some concerns include over-reliance on the model, like, For example, the lack of expertise among educators. This is important to understand that the limitations of LLMs, to understand their limitations and also use them only as tools or support, learning support to enhance learning, to not completely rely on them. Also, human studies will be unlikely to go away, as few shot or zero shot LLMs were found to be often outperformed by models fine-tuned on human data or human annotations. Most CSE studies also focus on English and other major languages and address mostly the Western cultures. But there are many important questions in social science that require large-scale, multilingual, and multicultural analysis. For example, studying how languages evolve or how values evolve across cultures. And LLMs are limited by the underrepresentation of minority communities and the low resource languages in their training data. So that is why you can see huge disparities in performance. Also, we are facing a data shortage. I didn't know this until recently, especially for textual data. So I'm really curious if you know the answer to this question. So in this paper, they try to predict when we will run out of data. So if rapid growth in data set sizes continues in this way, models will utilize the full supply of public human text data between this year and this year. I'm really curious what you think. What are the years? 2028, 2030? Okay, other ideas? (2026, 2027, 2035? I see. Okay, let's see. Pretty soon, right? So, yeah, based on this graph, they predicted that it will be about between 2026 and 2032. So yeah, if the rapid growth in data set sizes continues and models will utilize the full amount of public data, then at some point between 2026 and 2032, 1 or 2, or maybe 1 or 2 years earlier than that, models will be overtrained and we will be running out of data. So it is important to create more efficient models that don't need so much data, but also investigate alternative data creation strategies. So for example, we can look at synthetic data sets. So given an existing data set, we can apply changes to create a semantically preserving data set, but with a different style, for example. And another method is to look into knowledge distillation. This is another popular technique that transfers knowledge from a larger, more complex model called the teacher model to a typically smaller, simpler model called the student. And LLM outputs can be utilized as synthetic data examples for student learning. So having all these research directions, going back to the question, what should I work on? As we also say in the paper, it's good to consider your previous experiences, look around at your community, explore your curiosities about language and also about people. This is really important. And also find what resonates with you the most. And building on this foundation, then you can identify the tasks that connect to your own motivations. And also don't forget to have fun. That's also very important, as things can be stressful, but worth it. So yeah, we say to choose your own adventure and start from your own motivation. And we also built this diagram we share in the paper in a choose your own adventure way. You can look through this diagram, start from your motivation, to guide you through all these research directions, and choose based on your genuine interest and not just what is a trendy hot topic at the moment. And for more guidance and resources, I wanted to share our monthly mentorship panels. You can check our ACL mentorship page and also the Twitter account where we share every month details about when the mentorship sessions are gonna happen and who are the panelists. And the next one is gonna be in September, but we will also be in person at EMNLP in Miami. So I really hope to see many of you there. And also for more research ideas and inspiration, I also enjoyed the presentation from Professor Christopher Manning, Academic NLP Research in the Age of LLMs, Nothing But Blue Skies. And also I enjoy reading the article from Sebastian Ruder, NLP Research in the Era of LLMs. And I was really happy that he got inspiration from our paper. And speaking of blue skies, I also, if you enjoy great weather and research, I wanted to announce that I'm hiring PhD students to start in the winter. And at Santa Clara University, for more information about my research, I do research in multimodal and multicultural. You can find more information about this on my website, and also I attached a form where you can apply. So yeah, thank you so much. I'm happy to take any questions. Yeah, the recording will be available at Cohere's YouTube channel. I see some questions about that. Thank you so much, Alagu. I'm really happy you found it useful. Great. I will also share the slides on Twitter, or maybe in the description of the video. I can talk later with Ahmad. Yes, Ahmad, you have a question?
Not a question, but I guess more of a comment or like. So I recently uh, watched a few presentations and read a few debates on Twitter, and I feel like one of the problems that a lot of people recently started working on in NLP these days is the problem of tokenizers. Like the tokenizers are not really good in NLP and are cause of many root issues. So I guess that can be a good addition.
Thank you. Yes, our lab doesn't really work with tokenizers. I think that's why, we're using them indirectly, but we didn't really think of how to improve them. That's why we didn't add it in the paper, but it's a really good, I saw many discussions about that on Twitter, so it's a good area to look into. Thank you.
I have another question. What problems do you think are like very well solved by LLMs? Like, for example, if this is a problem that has been solved completely by large language.
Can you repeat?
So what? So do you think there is any problem that has been completely solved by LLM?
Oh, I see. Completely solved. I'm not sure. They seem to solve a lot of benchmarks, so it gives this impression that, like summarization, for example, they do a good job with that. But maybe it also is based on the data, on the evaluation you're using. For summarization, for text generation, also there's not, the evaluation metrics are a bit noisy, and that's another area of research that's useful to look into, how to evaluate the generation. So I'm not sure if I would say something is completely solved. It might appear at some point when all the benchmarks are beaten, but then a new benchmark can appear. You can put that model in the real life with a lot of noise and complex scenarios, and then you see other challenges appear. So yeah, that's my opinion. Prativa, you have a question?
Yes, hi. Good day to all, and hope everyone is doing well. I have a question to you. Like, for example, do you have any research paper or any suggestion on, relationship extraction from the tables? Let's say if I have a data set which has table name, column description, and table description. So based on this, is there the possibility that we can use some NLP techniques to extract the relationship? Like, for example, creating a logical model of that sort.
I see. I don't have myself, I don't work with tables, but I think someone in my lab, he's been using tabular data or database, I think to SQL. I can look into some papers of his. Also, I heard of this research problem before. I think at Bloomberg, they're doing this kind of research. So yeah, I'm sure you can find many papers that look into table data, tabular data.
Okay. Yeah. Thank you.
Thank you. Okay, someone is saying you can use Table Transformer by Microsoft or use graphs. Okay, great. I'm really happy you help each other. That's what community is for. Also, someone is asking, let's see, a lot of questions. Great. If I do research on neuro-inspired NLP, maybe aligning representations from the brain to latent spaces in language models. That would be interesting. Yeah, neuro-inspired NLP. I don't do research like that, but it's interesting, yeah, to collaborate with neuroscientists. And you could argue that the whole deep learning neural network is inspired from neuroscience. But we can look much more into the depths of how the brain works. Then, what are recent advances in child language acquisition? Also, that's not the field I'm working on. You can find more, like the exact papers we mentioned in the paper. I know that they're not like, the AI community is not focusing so much on that aspect. So there's plenty of work to be done in that direction, like creating bigger benchmarks, using multiple modalities, like you can use vision and sound and language and see how children learn language. I think there's plenty of work to do in that area. But I encourage you to look into the paper for more the exact citations that we share. Also, what's your take on the bitter lesson? Specifically, do you have any suggestions for how early stage researchers should factor that into their problem choosing process? What is the bitter lesson?
Hi, so that was me. So, okay, so the bitter lesson is this article by Rich Sutton. Basically, in that he makes the argument that in the long run, kind of custom architectures and kind of custom, inductive biases will always be worse off than kind of more data and just more compute. So, the reason I asked that question was a lot of times in domain specific, like applied settings, we tend to think of creative approaches to modeling a certain problem. But when we think of in the long run, it's like these domain specific approaches will always get beaten by some general purpose approach that some probably large organization like OpenAI or one of those people will beat it. So I sometimes I personally feel like that's kind of demotivating in the short run. Like, what's the point of working on this super domain specific approach when something else is going to beat it? I guess my question is, how do you do you think that should be a concern while choosing a problem, and kind of how do you approach and navigate that? Thanks.
Thank you for the explanation. Yeah, that's interesting, and I can see that happening. So a lot of, for example, these language models can, well, they're advertised like solving everything, right? Like as you said, they might solve a lot of domains. So why focusing on just particular ones if something bigger comes and solves everything, right? But I think it's just like, I don't know how to call it, like the illusion of solving everything. Like maybe coming back to that example of the benchmarks, maybe they solve certain benchmarks, but still maybe they don't solve the real problem. And you have to think, if your benchmark is solved, is the problem with the benchmark? Is the task sufficiently challenging, or you need to collect more data, more complex scenarios to further test your model? And I don't think there's an approach that solves everything. Like right now it appears so because of the they use a lot of compute and they're very complex, but the world is also very complex. So until we see them applied in the real world and across a lot of domains and working well, being reliable, and knowing exactly how they make the decision process, that's another thing, that being so big and so complex, they're like a black box, we don't know what's going on. It's hard to reliably use them in the real world. So I think in many companies, they prefer to use something that's a bit, maybe not as accurate, but they can understand what's going on, and they can account for they can further improve in that accuracy by using human in the loop or other strategies that makes the model more controllable, more reliable. Interesting. Okay, thank you for sharing, Ahmad. There's the bitter lesson and Sarah Hooker's response to. I'll check that out. It's very interesting. I didn't know there was a name for this. Yes, you have another question?
Yes. So this has to do with alignment and what I'm seeing some people kind of probably not the most core scientific research community, but somewhat adjacent kind of folks who are writing a lot about alignment, and it's not research papers per se, but more like long form articles and these kinds of pieces. And also, I'm sure there's also like solid research. I just haven't taken a look at it. But what is your take on just working on like the alignment problem in a general sense, not in a task specific way, but just alignment in general? Is that, do you feel like um, it's a fruitful and valid research direction? Because I find it hard to distinguish whether it's hype or whether it's some substance to it, that whole area.
I see. Yeah, I saw there's a lot of talk about this. There's also some books on alignment, and I think it's an important research direction. Like, I'm thinking about it in the sense from my perspective of what I'm interested in, like making sure AI aligns with human values across cultures, works well for everyone regardless of their demographics, like income, location, geography, all this. So I'm looking at it more from this perspective, and there's plenty of work to do in that direction, because these models were trained on data from the internet, which is mostly data from the Western countries, English data. So the values are from that part of the world, that population, and this doesn't align with the rest of the world. So there's plenty of work to do to bridge that gap. We have a paper, like together with Joan, we have a paper on bridging the digital divide, where we're looking at the income level and how multimodal models don't work well for data from low-income households. So images from like of common household objects like I don't know, cooker or yeah, some basic objects, and state-of-the-art models tend to not take those into consideration if they come from lower household incomes, because they tend to look a bit differently. So yeah, that's a clear example of misalignment and how we need to work to improve that.
That's a very interesting example. Thanks.
Thank you. So let's see, there are so many NLP papers being published nowadays, and it looks a bit like a race. How do you see this? How much of the current NLP research is actually making a long-term contribution? Yeah, I think we all think about that, and I share in the beginning that was a graph actually stopped at 2018, but I'm sure it spiked even more in later years. And yeah, it is a race. It looks like a race, and I'm not sure how many papers make a long-term contribution. We should wait and see, but for sure not all of them. And a lot of those papers are only about engineering, beating state of the art. A lot of times these papers tended to be more publishable. Like if you compare your model that you engineered, you added some extra things, it suddenly beats all the current benchmarks, and that's a reason to publish it. But then another model is going to appear much more complex and it's going to beat your model. So that might be an example of not long-term contribution. So I think a long-term contribution could be something that's more niche, or you think more in depth of the problem you want to solve, why you want to solve it, maybe something more like slow research. But then there's also low-hanging fruit. Let's say like you build on top of something and you improve it. So in my PhD, I did kind of a mix of both, because I also needed to finish the PhD to publish. right? But it's great to also have some other project on the side that can take a bit longer and you can have the time to think about. So yeah, a mix of both. I think it's good. Okay, we're a bit over time, so I'm not sure if to continue answering questions. Or Ahmad, you have any thoughts?
If you have like time and you want to, then you can. But if you don't have time, then we can conclude the session.
So it's okay. You said it's okay to stop here?
Yeah, it's fine. It's fine. We can stop here.
Okay, thank you so much. Yeah, check our paper for more in detail explanations and citations.